Hello everyone and welcome back to part 3 of a 3-part lecture series on validation and verification. And what we'll talk about now to wrap things up are the main types of verification. They include inspection, demonstration, test, and analysis. Now what we mean when we say inspection is a non-destructive examination of the product. So you use one of your 5 senses to look at the product or listen to it or touch it, and it may include some simple manipulation or some very simple measurements that may include like a ruler to look at something. And we're going to use in all these instances a car as an example. So you can walk up to a car and examine that it has power windows and power adjustable seats or air conditioning, and you look at the car and say, okay, from an inspection purposes, you've got it. Now, demonstration is where you may actually sit in the car and you now manipulate or interact with the car or product based on its intended or planned application or how it's to be used. So in the case of the car, you sit in it and start using now the actual switches to verify that the windows and seats work as intended, and the air conditioning actually gets to the temperature that you select. So here you're sitting in the car, you're interacting with the product and manipulating it and making sure that it works as intended. Test itself, this is a very formalized type of verification, and this is where you would walk up and use a controlled stimulus and you would measure the response and compare that response to a predefined output as specified by the requirements. So when you generate the verification test here, you define the stimulus very explicitly, you capture those results, and you now have a pass-fail criteria for those measurements. And the measurements are usually captured by things like an oscilloscope or voltmeter. Now in the case of the car here, we would, this is an example where it's required within 5.2 seconds to go from 0 to 60. So we'd have the car, we'd have a radar gun, and then we'd have a stopwatch. Between all three, we could make sure that we would then run this test and make sure that the product actually meets that requirement. Now, analysis is really where you might use models or calculations or even results of some lower level tests in conjunction to conclude something new about the product. And in the case of a car, you might develop an ANSYS mechanical model to look at the fatigue of the transmission. And you use those results to ascertain whether or not you might meet the reliability requirements. And hence, if you do, you can sign up for certain warranty periods on the automotive vehicle. Now, once you have all of these different types of verification methods, you then can create a verification plan. And the columns here represent the different system requirement numbers from 1.1 all the way to 6.2. And the rows here represent the different verification test numbers. And the first one here is test 1 would be an inspection, and it would verify system requirements numbers 5.1 and 5.2. The next test 2, would be an inspection of 1.2, 2.2, and 2.3 requirements. And then test 3 would be a demonstration where you would test requirements 1.1, 1.3, 2.1, and so forth. So you set this up, and as you can see, all the system requirements have been verified by some means. So, some are by demonstration, inspection, test, and so forth. None here show analysis, but this is just an example. Now, in conclusion, everything that we've talked about, requirements are the lifeblood of the product design. And what we do is validation at the start of the program. It's essential prior to doing anything. You have to understand your customer needs. You have to listen to your customer, and you document what your customer wants via requirements. And you use these requirements to hand them off to your designers and testers. Now, during the design process, these requirements, these high-level ones, are decomposed throughout the process depending upon what level of design you're looking at. And these lower-level requirements are always traceable to higher-level requirements. You can map to them and see where they came from. You just don't have a low-level requirement hanging out there for no reason. And then verification. This is where you evaluate your product against the requirements, and you perform this at all levels of integration. And then if you fail any of these, you feed back into the design process. You go back across the V and you start again on that particular area that you failed. And then at the end of the program, you confirm that what you've designed meets the customer needs. And then once completed, now you're ready for production. So that's it. I hope you've enjoyed all 3 of these lectures. Thank you.